What if I told you that machines are learning to see? Not just with cameras, but to truly understand the visual world and even to create it from scratch. This is the field of computer vision, and it's one of the most exciting areas of AI today. In the next 10 minutes, we're going to explore the two main families of computer vision tasks. First, the detectives, the AIs that analyze and understand images. And second, the artists, the AIs that generate and create new visuals. Let's dive in. Analysis is all about teaching machines to extract meaning from pixels. It's the what, where, and who of an image. This is the most fundamental task, image classification. The AI answers one simple question: what is in this picture? Is it a cat, a dog, a car, or a tree? It looks at the entire image and assigns a single label. Think of it like a very smart, very fast toddler pointing and naming objects. This might seem basic, but it's the building block for almost everything else we're going to talk about. These systems are trained on millions of labeled images, learning to recognize patterns like the pointy ears and whiskers of a cat or the four wheels and shiny body of a car. It's the first step in giving a machine a basic vocabulary of the visual world. Now, let's level up to object detection. This is where it gets really interesting. Object detection doesn't just say asterisk what asterisk is in the image, it tells us asterisk where asterisk those objects are. It draws bounding boxes around every relevant object and labels them. Imagine a busy street scene. An object detection model can simultaneously identify a car here, a traffic light over there, a pedestrian on the crosswalk, and a bicycle parked on the side. This is the core technology behind self-driving cars, allowing them to see and locate other vehicles, people, and road signs all at once, making real-time decisions to navigate safely. It's not just about naming, it's about mapping out the environment. From boxes, we move to pixel-perfect precision with image segmentation. This takes it to a whole new level. Instead of drawing clunky boxes around objects, segmentation maps every single pixel in an image to a specific category. There are two main types. First, semantic segmentation, which answers the question, what does this pixel belong to? It'll say, this pixel is a person, this pixel is part of the road, and this pixel is the sky. It differentiates between general classes of objects. Then there's instance segmentation, which is even more detailed. It says, this pixel is person number 1, this pixel is person number 2, and this pixel is car number 1. It can tell the difference between individual objects, even if they're the same type. Why is this so important? It's crucial for things like medical imaging, where doctors need to pinpoint the exact boundaries of a tumor to plan a surgery, or for augmented reality apps that need to place a virtual object perfectly behind a real-world person. It's about ultimate precision. Finally, in the analysis family, we have a specialized but very popular task, facial recognition and analysis. This is a form of analysis focused entirely on human faces. It can identify or verify a person's identity, that's the facial recognition part you use to unlock your phone. But it can also go much deeper to analyze attributes like approximate age, emotion, is the person happy or sad, and even subtle cues like whether someone is blinking or looking at the camera. You see this technology everywhere, from securing your devices and tagging friends in photos to powering those fun social media filters that place glasses or hats perfectly on your face. Now, let's flip the script. What if the AI isn't just interpreting the world, but actively creating it? This is the generative side of computer vision, and it's an area that is absolutely exploding with creativity and innovation right now. First up is the one you probably heard about, image generation. This is the incredible ability to create brand new, completely original images from just a text description or some other input. Tools like DALL-E, Midjourney, and Stable Diffusion have made this accessible to everyone. You provide the imagination something like a cat astronaut wearing a helmet, eating a croissant in a bakery on Mars, and the AI acts as your personal, unbelievably fast artist, bringing that wild idea to life in seconds. This isn't just stitching together existing images. It's synthesizing a new one based on its understanding of concepts like cat, astronaut, and Mars. Next, we have image-to-image translation. Think of this like a visual filter on steroids. The AI takes one image and transforms it into another, often changing its style or specific attributes while keeping the core content. It can turn a photo of a summer landscape into a winter wonderland, complete with snow on the trees. It can transform a horse into a zebra by applying the stripe pattern. Or, on a more practical level, it can take a simple sketch of a shoe and turn it into a photorealistic product image for an e-commerce website. It's a powerful tool for artists, designers, and creators to rapidly explore different visual styles. But what about the photos we already have? That's where super resolution and denoising come in. They are the enhancers. Remember those old TV crime shows where the detective says enhance? And a blurry, pixelated license plate becomes crystal clear. Well, that's no longer science fiction. Super Resolution AIs can intelligently add detail to low-resolution images, making them sharper and clearer. They don't just enlarge the pixels, they hallucinate plausible details to fill in the gaps. Similarly, denoising AIs can clean up grainy photos taken in low light, recovering clean, crisp visuals from noisy, messy data. It's like a digital restoration artist, but for your everyday photos. And finally, we bring generation to the world of video with video synthesis and interpolation. This is all about animating the world. It can mean generating entirely new video frames to make slow-motion footage incredibly smooth, a process called interpolation or frame generation. Or, it can even mean animating a still image, like making the person in an old family portrait subtly move, blink, and smile, bringing a static moment to life. This technology is pushing the boundaries of visual effects, content creation, and even how we preserve our memories, blurring the line between a photograph and a living moment. So, as we've seen, computer vision is a two-sided coin. On one side, you have the detective, the analytical power to identify, locate, and understand our visual world. This is the brain behind autonomous vehicles, medical diagnostics, and advanced security systems. On the other side, you have the artist, the generative power to create, enhance, and transform pixels. This is the engine for new forms of art, design, and entertainment. Together, these tasks are giving machines the gift of sight, and in doing so, they're not just changing technology, they're redefining human creativity and perception itself. Thanks so much for watching. Which side of computer vision fascinates you more, the analytical detective or the creative artist? Let us know down in the comments. And if you enjoyed this, don't forget to like and subscribe for more deep dives into the amazing world of AI. See you in the next one.